Hi, I'm Les from BrainSparks.ca, and this series is about big data explained. It is a practical guide for non technical professionals and students. It offers a clear and accessible introduction to the world of big data without technical background and jargon, with real world examples, simplified explanations, and strategic insights. This guide and series unpacks the core concepts behind big data, what it is, how it works, and why it matters. So, if you're viewing this, you'll get to explore how data is collected, stored, processed, and used to create value across various sectors. It also highlights modern tools, frameworks, and governance practices to help professionals ask the right questions, make informed decisions, and collaborate more effectively with data teams. So, whether you're in business, government, healthcare, environmental sector, or nonprofits, this series will help be your go to resource to navigate the big data landscape confidently. Data has always been at the heart of decision making, whether it's a merchant tracking inventory by hand or a government agency assessing public health trends. What's changed in recent years is the sheer scale, speed, and variety of data available to us. We're now living in a world where businesses, governments, and communities generate and collect more data than ever before. So much, in fact, that traditional tools and mindsets can no longer keep up. This is where big data comes in. At its core, big data refers to data sets that are too large, fast, or complex to be handled by conventional systems. But big data is more than just a lot of data. It represents a shift in how we understand the world, an opportunity to uncover patterns, make predictions, and inform decisions in ways previously unimaginable. For non technical professionals, the concept of big data can often feel overwhelming or out of reach. The language is dense, the tools are unfamiliar, and the field evolves quickly. Yet, you don't need to be a data scientist to work with big data, you just need the right foundation. So, you need an understanding of the concepts, the confidence to ask smart questions, and the ability to connect data to your goals. And the series is designed to give you that foundation. So you'll learn what big data really means and what it doesn't, where it comes from and how it's used, which tools and technologies are behind the scenes, how to collaborate more effectively with data experts, and how to navigate the ethical and strategic implications. Using real world examples, plain language, and practical insights, the series aims to simplify big data, not by teaching you how to code, but by showing you how to think like a modern professional in a data rich world. So, regardless of what industry you're in, big data is shaping your landscape. The more you understand it, the more equipped you'll be to adapt, lead, and innovate. So, let's dive in. Start with what we call the five V's of big data. When professionals talk about big data, they're often referring to more than just a lot of information. What truly makes big data big is not only its volume, but also its velocity, variety, veracity, and value, commonly known as the five V's. These five dimensions help us understand the nature of big data and the challenges and opportunities it presents. Let's take a closer look at each one. Volume is the scale of data. Big data deals with enormous quantities of information. We're talking about terabytes, petabytes, even exabytes, a scale well beyond what traditional databases are designed to handle. Retailers like Amazon process millions of customer transactions every day. Social media platforms store billions of user posts, photos, and videos. And if you think about a platform like YouTube, it's storing gigabytes per single video sometimes. So the key takeaway is that large data sets enable broader insights, but only if they can be stored, accessed, and analyzed efficiently. Velocity is the speed. It's not just about how much you have, it's about how fast it's coming in and how quickly you can act on it. From real time social media updates to live sensor data from smart devices, velocity is a major differentiator in today's data environments. Ride sharing apps like Uber rely on real time GPS and traffic data to match drivers and riders. Financial markets stream live trading data that must be analyzed in milliseconds. High velocity can create both pressure and possibility. Can your systems, your team, respond fast enough to act on the data while it still matters? Variety is the diversity of data sources. Big data comes in many forms like text messages, images, audio, video, logs, sensor outputs, social media posts, and much more. Not all of it is neatly structured or formatted. In fact, most of it isn't. The hospital may analyze patient records, which are structured data, medical imaging, which may be structured or unstructured, and doctor's notes, which could be semi structured. A city's smart traffic system might combine weather reports, GPS data, and surveillance footage. The variety makes integration and analysis more complex, but also more powerful. Richer data can lead to deeper insights. Veracity is the trustworthiness of data. So, not all data is accurate, clean, or unbiased. Veracity refers to the quality and reliability of the data you're working with. Dirty data leads to bad decisions. Inaccurate customer profiles in a CRM system can result in failed marketing campaigns. Biased training data and a hiring algorithm can lead to discriminatory outcomes or favoring inappropriate candidates or unqualified candidates. Non technical leaders must think, is this data complete, timely, and trustworthy? Data governance and quality checks are essential. And value is the impact of the data. Ultimately, big data isn't just about having more, it's about doing more. So, value is what you gain from interpreting data to solve problems, serve customers, reduce costs, or innovate. A nonprofit uses data to improve program delivery and fund allocation. A manufacturing firm uses predictive maintenance data to avoid costly downtime. No matter how advanced your tools are, if the data doesn't lead to action or insight, it's not valuable. The role of non technical professionals is to focus on what questions need answering and how data can inform those answers. So, why do these 5 V's even matter? Understanding the 5 V's helps simplify why big data is different than traditional data and why it requires a new approach to strategy, tools, and teamwork. It also offers a framework for evaluating any data driven project. Is the data set large and fast moving? Are we pulling from diverse sources? Can we trust what we're seeing? Will this data help us make better decisions? These are the kind of questions that professionals across all sectors with all backgrounds should feel empowered to ask. Where does big data come from? Big data doesn't appear out of thin air, it's generated constantly by people, systems, and devices around the world. Understanding the origins of big data helps professionals better appreciate its potential, its limitations, and its relevance to their work. This episode covers the major sources of big data and introduces the types of data commonly used in modern analytics. So, number one would be people generated data. Humans generate an astonishing amount of digital content every day, even through routine activities. So, that could be your social media posts, likes, shares, and comments, online search queries and website activity, e commerce purchases and product reviews, email and customer service interactions. These actions all leave a digital footprint. They can be tracked, analyzed, and used to understand behavior, preferences, and trends. Number two would be machine generated data. So machines and devices constantly produce data without any human input. That could be server logs and system performance data, call detail records from telecom networks, security systems and surveillance footage, ATM transactions and sensor data. Machine generated data is typically large in volume and highly structured. That makes it useful for even system monitoring and automation. There's also sensor and IoT data. With the rise of the Internet of Things, or IoT, physical devices now collect and transmit data autonomously. So, some examples could be smart thermostats, home appliances, GPS trackers, mobile phones, machines in factories, wearable health monitors like your smartwatch. IoT data tends to be real time and continuous, making it valuable for operations, logistics, and predictive analytics. There's also public and openly sourced data. So that could be from governments, institutions, and research bodies. And they often provide this data for public use. So that could be census and demographic data, environmental and weather data, traffic data, data sets on crime, transit, education, and public health, academic research repositories. This data can enrich internal data sets and support evidence based policy, social research, and community innovation. Uh, Big data also comes in different formats, like as we mentioned, structured data, semi-structured data, and unstructured data. Recognizing these helps professionals better understand what tools and approaches may be needed for their analysis. So structured data fits narrowly into rows and columns, like what you'd see in a spreadsheet or database. So that could be sales transactions, customer contact records, employee payroll data. It's relatively easy to use and store and analyze using traditional tools. Semi-structured data has some organizational elements, but doesn't fit neatly into tables. So that could be emails with headers and body text. It could be web pages with metadata. It could be XML or JSON files. It requires more flexible tools to interpret and analyze. And unstructured data is raw, unorganized information that doesn't follow a clear format. That could be video and audio files, images, scanned documents, social media content, and customer reviews. And unstructured data represents the majority of big data. And while it's harder to analyze, it can provide very rich insights when interpreted properly, especially with the help of AI and machine learning. Traditionally, data was collected, stored, and analyzed in batches. But now, with advances in technology, data can be processed in real time as it's generated. Streaming data is especially important in areas such as fraud detection because it can monitor live transactions. Healthcare, so it could be tracking patient vitals like your heart rate or breathing rate in real time. And traffic management, so it can adjust signals based on congestion data. This shift increases the urgency and complexity of how we handle data, but it also unlocks real time responsiveness and agility. Data is everywhere. It's created by people, machines, sensors, and public bodies. Not all data is created equal. The format, quality, and speed affect how it can be used. Now, understanding your data sources can help you assess what's possible and what's not. So, in short, if you want better insights, you need to know where your data is coming from, what it looks like, and what it's telling you. The journey from raw information to actionable insights begins with how data is collected, stored, and organized. For non technical professionals, it's not necessary to understand the intricate mechanics, but it's essential to grasp the process, tools, and challenges involved in managing big data at scale. Modern systems can collect data through a variety of channels. One, we have automated collection. Most big data is collected passively through digital systems that log activity or sense changes. So, for example, web analytics platforms track user behavior on a site, mobile apps capture geolocation data, machines report operational metrics in real time. Second is APIs, or application and programming interfaces. APIs allow systems to talk to one another and exchange data. So, a weather service API could pull forecast data into a logistics dashboard, or a social media API could feed engagement metrics into a marketing tool. APIs are essential for integrating external data sources into your internal systems. And third, we have manual input and uploads. Although less scalable, humans still input and upload valuable data. For example, someone could fill out a survey, upload a CSV file to a shared drive, enter client notes into a CRM system. But manual data entry introduces potential for errors, so validation processes are important. Once data is collected, it must be stored in a way that makes it accessible, secure, and scalable. So you could have a data warehouse. This is traditional storage for clean, structured, unprocessed data, ideal for reporting and dashboards. There's a number of tools on the market like Snowflake, Redshift, and BigQuery. Warehouses are optimized for analysis, but not for storing raw or unstructured data. Second, we have data lakes. Data lakes store raw data of all types, structured, semi-structured, unstructured, in a central repository. Some examples include S3, Azure Data Lake, and Apache Hadoop. Lakes are ideal for data science and machine learning, where data may need to be processed in new ways later. Cloud storage is third on our list, and cloud platforms allow for scalable, flexible, and cost-efficient storage. The benefits are pay-as-you-go pricing, fast access, global availability, and integration with processing and analytical tools. So some examples would be AWS, Google Cloud, and Microsoft Azure. But we have to consider how frequently data is collected because depending on the business need, that may matter. Batch collection is when data is gathered and processed at set intervals. That could be hourly, nightly, weekly. It's suitable for reports, forecast, and trends analysis. Real-time streaming collection of data is when it's continuously gathered. So as it happens, this is suitable for alerts, fraud detection, or time-sensitive operations. Many modern systems support both methods depending on the application. Behind the scenes, data engineers design pipelines that connect sources, storage, and analysis tools. At initial step is ingestion. So that's when you bring the data in from apps or sensors. The second step is storage, saving it in an appropriate format and location. Third step is processing, cleaning it, combining it, or transforming it. And fourth is access, making it available to analysts or applications. You don't need to build the plumbing, you just need to understand the flow so you can ask the right questions and to the right people. There are some challenges in collecting and storing big data. Even with powerful tools, organizations face several hurdles. For one, there's scalability. Can your systems handle data growth? Data quality. Are you collecting accurate, relevant, and clean data? Security. Is your data encrypted and access controlled? And the cost. Are you storing more data than you need? For non-technical professionals, it's important to align data collection with clear goals. More data isn't always better. Sometimes it's just more noise. So some key takeaways. Big data collection can be automatic, integrated via APIs or manual. Data warehouses are for structured, clean data. Data lakes are for raw, diverse formats. Cloud platforms have made storage scalable and accessible to all sizes of organizations. And understanding how data flows helps teams and others collaborate better on analytics and strategy. Let's talk about processing big data. Once data has been collected and stored, the real work begins. In its raw form, big data is often messy, unorganized, and overwhelming. To uncover insights and make it useful for decision making, that data must be processed, cleaned, transformed, and prepared for analysis. But processing big data is no small task. Traditional methods that once worked well for spreadsheets and small databases simply can't keep up with the volume, speed, and complexity of the modern data environments. This episode covers what happens between the moment data is collected and the moment it becomes insight and why that matters for professionals in every field. Imagine trying to cook a gourmet meal with unwashed vegetables, expired ingredients, and no recipe. That's what working with unprocessed data feels like. Raw data is often riddled with issues, duplicates, missing fields, outdated information, or inconsistent formatting. Processing solves these problems by turning data into something clean, reliable, and ready to use. More importantly, data processing helps ensure that decisions made from data are based on truth, not noise. Poor processing can lead to flawed insights and flawed decisions. There are several key processing tasks. And although data processing is largely held by engineers and data scientists, non technical professionals can benefit from understanding the steps. The first one is data cleaning. This is the digital version of tidying up, removing duplicates, correcting errors, and filling in missing values. Clean data is the foundation for any analysis. So, for example, if a customer's birth date is listed as 1901 or their name appears as 3 times with different spellings, it's likely a data quality issue. Second step is data transformation. Raw data doesn't always come in a clean, usable format. It may need to be standardized, reformatted, or reshaped to fit the requirements of an analytical tool. So, for example, converting timestamps to a standard time zone, changing yes or no entries to ones and zeros, or grouping data by category. Third step is data integration. Sometimes insights require data from multiple sources to be combined. So that could be customer data from a CRM, web traffic from Google Analytics, and financial data from an accounting system. The challenge is making sure that all of these systems speak the same language. The step often involves resolving name conflicts, aligning timeframes, and removing redundancies. Fourth step is aggregation and summarization. To make data more digestible, it's often summarized. Daily transactions might be rolled into monthly trends or survey responses aggregated into average scores. This step is helpful in highlighting patterns and enables reporting and visualization tools to present findings in a meaningful way. Next, let's compare batch processing versus real time processing. Not all data needs to be processed immediately. There are two dominant approaches depending on use case. Batch process Batch processing is when data is collected over a period of time and processed all at once. The main use cases are generating end of day financial reports or running weekly marketing performance summaries. The tools often used in this are Hadoop, Apache Hive, and traditional ETL pipelines. ETL is extract, transform, and load. Batch processing is efficient when immediate results aren't required, but it's less helpful for situations that demand instant response. Real time or stream processing involves processing data as it's generated in near real time. This could be involving monitoring fraudulent credit card transactions or adjusting prices or inventory dynamically during online shopping. Apache Spark Streaming, Apache Flink, and Kafka are tools often used for this task. Real time processing enables faster decision making, but also demands more complex and responsive infrastructure. Although you don't need to use these tools directly, it helps to be familiar with their names when working alongside data teams. So Apache Hadoop is a pioneer in distributed processing. It's capable of handling massive data sets by breaking them into smaller chunks and processing them across many machines. Apache Spark is known for faster processing and is often used for real-time analytics. Flink, Storm, and Kafka are tools often used in real-time data processing and event-driven applications. ETL tools often help automation, extraction, transformation, and loading of data into analysis ready formats. Understanding what these tools do helps you better understand scope, timelines, budget, and align your business needs with the technical requirements. So, what is the human role in processing? While machines and tools do the heavy lifting, humans create the rules. What should be cleaned? What is an error versus a valid outlier? Which formats are best suited to your reporting goals? These decisions are often influenced by domain knowledge, the expertise that only business professionals like you can provide. As a non technical leader or team member, your role would be to help define what data quality looks like, flag inconsistencies or anomalies, and then validate whether processed outputs make sense. The key takeaways are processing turns raw, chaotic data into something clean, usable, and trustworthy. The difference between batch and real time processing affects how quickly decisions can be made. Tools enable massive data workloads, but strategic input from non technical professionals remains essential. And understanding the flow of data from collection to analysis improves your ability to collaborate and make smarter, data informed decisions. How do we make sense of it all? Big data by itself is not valuable. It's just raw material like unmined ore or uncut diamonds. The real value comes when we refine it into insight, something that helps people and organizations make better decisions, solve problems, or innovate. This episode explores how organizations extract meaning from big data through analytics, the different types of insights that can be generated, and how professionals can use this information to drive real outcomes. So, what is data analytics? Analytics is the process of examining data to uncover patterns, trends, and relationships. It transforms numbers into narratives, facts into strategies, and uncertainty into clarity. While the techniques and tools can be complex, the basic purpose is simple: to turn information into intelligence. In big data environments, analytics enables us to find meaning amid massive and often messy data sets. Whether you're improving patient care, optimizing supply chains, or understanding customer behavior, analytics can help cut through the noise. There are four main types of analytics, and each one offers a different level of insight. With descriptive analytics, this is what happened. This is the most basic form, reporting on past events. Some examples could be a previous month sales report, website traffic dashboard, and year over year comparisons. Descriptive analytics is foundational for understanding performance and spotting general trends. Next is diagnostic analytics. This is why did it happen? This dives deeper into the cause behind the outcomes. For example, investigating why customer churn spiked last quarter, analyzing regional performance differences, exploring correlations between staffing levels and service delays. Diagnostic tools can help identify root causes and contributing factors. Next is predictive analytics. What is likely to happen? Using historical data and statistical models, predictive analytics can estimate future outcomes. So, for example, forecasting demand during peak shopping seasons, predicting which patients are at higher risk of readmission, estimating equipment failure based on sensor data. This type of insight is essential for planning, risk management, and proactive action. And fourth is prescriptive analytics. This is what should we do? Prescriptive analytics suggests courses of action based on data. So this could be recommending the best delivery route based on weather and traffic, suggesting a personalized marketing offer to a customer, or allocating hospital resources dynamically during a health crisis. This often involves optimization algorithms and AI. While it is complex, it can dramatically improve operational efficiency. And you don't need to be a data scientist to work with data. You just need the tools that bridge the gap between raw data and actionable insight. Some common tools that you may have heard of or used: Excel, Google Sheets. These can be very powerful for filtering, pivot tables, and basic visualization. And then you've got Tableau and Power BI. They're pretty user friendly platforms for creating dashboards and interactive reports. Next up are things like Google Data Studio, CRM, and ERP systems. They're great for building visual dashboards with live data feeds, and they have a lot of built-in analytics features. These tools help surface insights in a visual and accessible way, even those if you can't write code or queries. And then you want to tell a story behind these numbers. Raw numbers rarely inspire action on their own. The key is translating those numbers into a compelling, context rich narrative. Why do we want to do this? What story does this data tell? Who is the audience? What do they need to understand? What's the key takeaway? What's the recommendation? So, for example, instead of reporting customer satisfaction dropped 12%, an effective insight might be customer satisfaction dipped 12% in Q2, primarily driven by slower response times in our support center, especially on weekends and holidays. Addressing staffing on weekends could improve customer experience significantly. This level of storytelling doesn't require technical skills, but it does require critical thinking, context awareness, and communication. Modern analytics increasingly incorporates artificial intelligence and machine learning to find patterns that humans might miss. These systems learn from data and can make predictions or even decisions on their own. For example, recommending products based on previous shopping behavior, detecting anomalies in financial transactions, optimizing advertising placements in real time. While you may not build these systems yourself, you will likely work alongside them. Understanding their capabilities and limitations is key to using them responsibly. So, in this episode, we covered how analytics transforms raw data into insight that supports better decision making, understood the four key types of analytics, which are descriptive, diagnostic, predictive, and prescriptive. Tools like Power BI and Tableau make data accessible to non technical users. Storytelling is essential. Data must be framed in context to drive action. AI and machine learning are powerful tools, but they still rely on human oversight and domain expertise. Now let's look at big data in action. I have several use cases across various industries. Big data, it's not just a buzzword. It's being used across nearly every sector to solve real problems, unlock new opportunities, and drive innovation. From improving healthcare outcomes to streamlining supply chains, big data's impact is visible and growing. This episode offers a tour through several industries to show how big data is being applied in the real world. You don't need to be technical to understand the value. It's about outcomes, decisions, and better services for real people. Let's talk about healthcare, where we can make smarter decisions and improve care. In healthcare, big data has the potential to save lives. Hospitals, clinics, insurers, and researchers are using data to deliver more efficient and personalized care. For example, predictive analytics can help identify high risk patients before they need emergency care, enabling preventive interventions. Electronic health records, EHRs, consolidate patient information across providers, improving diagnosis accuracy and care coordination. Medical imaging analysis using AI speeds up the detection of conditions like cancer or stroke. Population health analytics can help public health teams track disease outbreaks and vaccination rates. The impact is reduced readmission rates, more efficient resource use, and improved patient outcomes. In retail, we have personalization and precision. Retailers are leveraging big data to understand customers, optimize operations, and predict trends. Some examples include recommendation engines that suggest products based on browsing and purchase history, like Amazon, Netflix, or even Spotify. Inventory analytics help avoid overstock or understand situations by forecasting demand at the SKU level. Customer sentiment analysis on social media and reviews guide marketing and product development. And in-store analytics track foot traffic patterns to improve layout and promotions. The impact is higher customer satisfaction, reduced waste, and increased sales conversion. In finance, financial institutions were among the first to adopt big data to enhance risk management and fraud detection. Some examples include real-time fraud detection systems flag unusual transactions instantly. Credit scoring algorithms assess risk using a broader range of behavioral and alternative data points. Trading algorithms use massive data sets to detect arbitrage opportunities in milliseconds. And compliance analytics monitor transactions to detect suspicious activity for anti money laundering purposes. The impact is faster transactions, stronger fraud prevention, and improved financial forecasting. In the public sector, there's smarter cities and policy impacts. Governments use big data to improve public services, plan smarter cities, and shape better policies. Some examples include traffic and transit data to help optimize public transportation schedules and reduce congestion. Open data portals allow citizens, researchers, and entrepreneurs to analyze and build upon government data. Social service data integration improves coordination across departments to better serve vulnerable populations. And policy simulation models use historical and real time data to anticipate the impact of new legislation. The impact is more efficient services, data informed policy, and increased transparency. For manufacturing and logistics, we've seen the rise of predictive operations. Big data supports Industry 4.0, the automation and smart optimization of industrial processes. Some examples include predictive maintenance using sensor data to forecast when equipment is likely to fail, which can help avoid downtime. Supply chain analytics track shipments and delays across complex global networks. IoT sensors on factory floors monitor temperature, humidity, and pressure to ensure consistent production quality. The impact is cost savings, fewer disruptions, and high product quality. In agriculture, we have data driven farming. Farms are increasingly using big data to boost crop yields and manage resources more effectively. Some examples include precision agriculture that uses GPS and satellite imagery to apply fertilizer or water only where needed. Weather and soil data can help farmers plan optimal planting and harvest times. Market analytics enable better timing of produce sales for maximum profit. The impact is reduced environmental impact, improved yields, and more sustainable operations. In education, we can have personalized and proactive learning. Educators and institutions are using big data to enhance the learning experience and improve student success. Some examples include learning analytics to track student progress and flag those at risk of falling behind. Adaptive learning platforms adjust content difficulty in real time based on learner performance, and institutional analytics to help universities allocate resources and plan new programs based on enrollment trends. The impact is improved student outcomes, early intervention, and efficient program development. Some takeaways include big data is already using data across industries to deliver tangible results. You don't need to be technical to engage with big data projects. You need to understand the use cases, ask the right questions, and align efforts with business goals. Looking at examples from other industries can spark ideas on how your own sector might benefit from a data driven approach. You don't have to be a coder or data scientist to work with big data, but you do need to know which tools can help you access, interpret, and communicate data effectively. Thankfully, modern platforms have evolved to support non technical writers with intuitive interfaces, powerful visualization, and automation capabilities. Let's talk about a series of practical, widely used tools that professionals across sectors can adopt to participate more actively in data informed work. Modern organizations are becoming increasingly data driven, but the people closest to the real world problems, product managers, operations leads, HR directors, healthcare providers, they're not always trained in technical data analysis. By learning how to use the right tools, non technical professionals can explore trends and patterns independently, communicate findings more clearly, collaborate more effectively with data teams, and make informed decisions faster. So, still among the most used data tools worldwide, spreadsheets are more powerful than many people realize, which could be Excel or Google Sheets. Useful features are pivot tables for summarizing large data sets, conditional formatting to spot outliers, formulas for calculating trends and forecasts, data validation to improve accuracy. There's also add ons and extensions like Power Query and Excel for advanced data cleaning, Google Sheets connectors for real time app integrations. Spreadsheets are often a starting point before handing data off to more specialized tools. Next, we have business intelligence platforms. These platforms turn raw data into interactive reports and dashboards, no coding required. Power BI is a drag and drop visualization tool. It has built in connectors for Excel databases and cloud services. It has robust filtering and drill down options. Tableau is user friendly and good at visual storytelling. It's excellent for pattern recognition through dashboards. It has strong community support and learning resources. Google Looker Studio, which is formerly Data Studio, is free and web based. It connects easily to Google products like Ads, Analytics, and Sheets, and it's great for lightweight dashboards and live reports. You can use these tools for tracking KPIs, visualizing survey or financial data, and creating client or executive friendly reports. The next option is no code data automation tools. Automating repetitive tasks saves time and reduces errors. These tools require no programming but can connect apps and systems seamlessly. So Zapier and Make can connect tools like Gmail, Slack, Google Sheets, and CRM platforms. They automate workflows such as if a new lead signs up, add them to a spreadsheet and send them a welcome email. Airtable combines spreadsheet and database functionality. It's excellent for project tracking, content calendars, and lightweight CRMs. It supports automation, forms, and integrations. These various tools empower teams to manage and scale operations more intelligently without waiting on IT. There's data collaboration and survey tools. So that could be Typeform, Google Forms, or Microsoft Forms. Getting input from others, like employees, customers, stakeholders, is a valuable source of data. These tools make it easy to collect, share, and analyze that feedback. They're simple tools for building surveys and quizzes. They can export responses for further analysis, and they use conditional logic to tailor questions. Miro or Mural are collaborative whiteboards that help teams map data flows or customer journeys. They're useful for brainstorming and visually structuring complex information. There's also embedded analytics in business systems. So many enterprise tools now come with built-in dashboards and reports, which eliminates the need to export data elsewhere. So this could include UKG, Workday, Salesforce, Shopify, Bamboo HR, and EHRs. So that could be sales and customer data visualization, e-commerce trends and traffic analysis, workforce trends and operational metrics, patient level reports, and treatment histories. Professionals should learn how to access and customize the analytic features built into the platforms they already have access to. Next, if you're looking to sharpen your skills further, pick some tools and do some deep dive learning on those. So that could be Kaggle, which offers real data sets and competitions. So you can play a lot with real big data sets. There's Google Skill Boost. So that's data courses with free tier cloud environment access. And you don't need to be uh, doing anything super robust or serious. Just playing around with these different tools will give you confidence, and you can figure out what you like and what you don't like. Many powerful data tools are designed with non-technical users in mind, so don't be intimidated. Start with tools you already know or have access to and explore what's possible with add-ons or visual dashboards. Think of no-code platforms that offer easily accessible automation and analytics capabilities to start practicing with. And the goal isn't to become a data expert, but data literate and ask good questions, explore insights, and make more confident decisions. A very important aspect of big data is the governance, ethics, and privacy pieces. While big data opens up incredible opportunities for insight and innovation, it also raises serious concerns about how data is handled, who has access to it, and how it impacts people's lives. For non technical professionals, there's not just technical issues, there's strategic, ethical, and reputational concerns. This episode explores the foundational principles of data governance, introduces key ethical considerations, and outlines privacy responsibilities that every professional should understand. So, what is data governance? Data governance refers to the framework, policies, and practices that ensure data is managed responsibly and consistently across an organization. It covers who owns the data, who is allowed to access it, how it is secured, shared, and archived, and how its quality is maintained over time. Good data governance promotes trust, compliance, and accountability and prevents chaos. Why does it matter? Without strong data governance, teams may work from different versions of the same data. Decisions can be based on outdated or inaccurate information. Sensitive data may be exposed or misused. Organizations may fall out of compliance with laws and regulations. In short, data without governance is a liability, not an asset. Here are a few foundational elements that non-technical professionals should be aware of. One is data ownership and stewardship. Every data asset should have a designated owner. For example, the HR team owns employee records. Stewards are responsible for keeping that data accurate, complete, and up to date. Two are data quality standards. Governance policies should ensure that data is reliable, free of duplicates, errors, or gaps. Consistency, such as date formats or timestamps, and accuracy are key for trust. Third is access controls and permissions. Not everyone needs to access all data. Access should follow the principle of least privilege only as much as is necessary. Role-based access, audits, and encryption help reduce the risk of data breaches. Fourth is data retention and disposal. Regulations often require that data be kept for specific periods and securely deleted afterward. Governance ensures compliance with retention policies and prevents overcollection. Ethics is not just about avoiding legal trouble, it's about ensuring data is used in ways that are fair, transparent, and aligned with human values. Key questions to ask are people aware their data is being collected? Has consent been meaningfully obtained? Could our use of this data reinforce bias or discrimination? Are we using data for purposes that individuals didn't agree to? Would I be comfortable if this practice was made public? And you could even think about, would you be comfortable if your data was being used in this manner? When in doubt, put yourself in the shoes of the data subject, the person whose information you're using. Bias in algorithms: if your training data reflects societal inequalities, then your outputs will too. Surveillance concerns: collecting location or behavioral data without transparency can feel invasive. Manipulative targeting is using personal data to influence vulnerable groups, which raises red flags. So that could be in political campaigns or health misinformation. An ethical approach requires collaboration between business leads, data teams, legal, and community stakeholders. In many regions, privacy is a legal requirement. Failing to comply can result in fines, lawsuits, and reputational damage. Some common regulations include PIPEDA in Canada, which protects how private sector organizations collect and use personal data. There's GDPR in the EU, which grants individuals rights over their data, including the right to be forgotten. There's HIPAA in the US, which protects health information, and CCPA in California that requires businesses to disclose what data they collect and allows opt-outs. So even if you don't have to handle data directly, understanding these frameworks helps guide ethical and compliant decision making. Non-technical professionals play a vital role in shaping a responsible data culture. You can ask how data is being used and who is impacted. You can include privacy impact assessments and project planning. You can speak up when you spot ethical concerns or unclear data usage. You can help create policies that balance innovation with fairness. Remember that responsible data use is not a blocker to innovation, it's at the foundation of sustainable, trusted innovation. Some key takeaways are: data governance ensures that data is accurate, secure, and responsibly managed. Ethics and privacy are not optional. They are part of building trust and integrity in any data initiative. Non-technical professionals must be proactive in asking the right questions and upholding data values. Compliance with laws like PIPEDA, GDPR, and others is essential for risk management. Collaborating with data teams. Big data isn't just about tools and algorithms, it's about people. Behind every dashboard, forecast, or machine learning model is a team of professionals who collect, clean, and analyze and interpret the data. But too often, a gap exists between the technical data teams and the non-technical business professionals and users. Bridging this gap is critical. Effective collaboration ensures that data projects align with real-world needs, that insights lead to proactive and practical action. This episode explores how non-technical professionals can work more effectively with data teams and why mutual understanding is key to success. Understanding who does what in a data team. You don't need to become a data expert to work with one, but you should understand the basic roles and responsibilities within a typical data team. One are data analysts, so they focus on examining data to identify trends, patterns, and insights. They often build dashboards, reports, and visualizations. They translate questions into queries and data stories. So how would you work with them? Be clear about the questions you want answered and the decisions you're trying to support. Second are data engineers. They build and maintain the systems that move and store the data. They design pipelines to collect, clean, and organize data from various sources. They also ensure that data is accessible, accurate, and up to date. How would you work with them? Define what you need, how often, and from where, so they can design the right infrastructure. Third are data scientists. They use statistics, machine learning, and advanced modeling to solve complex problems. They focus on prediction, classification, and automation. They often explore what could happen or what should be done. How would you work with them? Frame your problems clearly, provide context, and discuss how model outputs will be used in practice. Fourth are data governance and privacy professionals. They ensure data practices comply with regulations and ethical guidelines. They manage policies for data access, security, and quality. To work with them, bring them in early when handling sensitive or personal data and when launching new initiatives. How to ask better data questions. One of the biggest barriers between business and data teams is unclear or vague requests. Here's how to ask for data more effectively. An example of a weak question is, can I get a report? A stronger version might be, can you show me a weekly trend of customer complaints by product line? Another weak question might be, what's the ROI of this campaign? A better version might be, based on leads and conversion rates, can we estimate revenue generated per dollar spent? Another weak question could be, is our website doing okay? A stronger version would be, how has user engagement changed since we updated the homepage last month? A good question is specific, actionable, and tied to a business decision. You also want to clarify the business context. Data teams often lack the day to day context that business professionals take for granted. They don't necessarily understand the nuances. Before asking for data work, explain why it matters, what decision it will inform, what success looks like, and any assumptions, constraints, or deadlines that may exist. The more context you provide, the more relevant and useful the results will be. You also want to collaborate throughout the data lifecycle. Don't just involve data teams at the end of a project, include them early and often. So during project planning, you want to work together to define the problem, discuss what data is available and what's possible. During analysis, you want to review early outputs and offer feedback. Also, ask clarifying questions and provide business insight. After delivery, use insights to take action, share what worked and what didn't, loop back for iteration if needed. Data is not a one time delivery, it's a conversation. Avoiding common collaboration pitfalls. Here are a few habits to avoid. Just give me the data. Data without context is rarely helpful and can be dangerous. Assuming technical teams know the business, they often don't provide background. Overloading with last minute requests. Good data work takes time and planning. Not using the insights delivered. If insights aren't acted on, everyone's time is wasted. Great data collaboration is a loop, not a line. Building a shared language. Data teams often speak in terms like standard deviation, confidence interval, or model accuracy. Business teams speak in terms of growth, retention, or cost per unit. Bridging this language gap requires curiosity and a willingness to learn and translate. Don't be afraid to ask what a term means or to offer a plain language version of what you need. Over time, teams that build a shared vocabulary work more effectively together and produce stronger results. So the key takeaways are understand the key roles on a data team and how to engage each one, specific outcome-oriented questions that connect to business needs, include data professionals early in planning, not just at the end, provide context, collaborate during analysis, and follow through on findings, build a shared language to lead to stronger, more productive partnerships. Future of big data. Big data is no longer a trend. It's a permanent fixture of modern business, governance, and society. But the landscape continues to evolve rapidly and relentlessly. New technologies, new forms of data, and rising public awareness are reshaping how we think about data and how we use it. This episode explores key trends shaping the future of big data, what they mean for non technical professionals, and how to prepare for what's next. The convergence of big data, AI, and automation. Big data and AI are increasingly intertwined. AI models are trained on large data sets, and those same models help extract faster, deeper insights from ever growing volumes of data. More organizations will use AI to interpret data at scale, automating reports, forecasting, and decision support. Natural language processing, NLP, will allow users to ask questions in plain English and get data-driven results instantly. AI will surface insights you didn't even know to ask for. What does this mean for you? Expect data tools to become more intelligent, more conversational, and more embedded in your daily workflows. You'll spend less time digging through dashboards and more time applying insights. Edge computing and the rise of real time data. Instead of sending all data to central servers or the cloud, edge computing processes data closer to where it's created on devices, sensors, and remote systems. An example could be a wind turbine processing its own sensor data to adjust blade angles in real time, or a hospital bed monitoring vitals locally and alerting staff instantly. More decisions will be made on the fly without waiting for centralized processing. For non technical professionals, this means faster responsiveness, but also more complexity in managing decentralized data environments. Synthetic data and privacy preserving technologies. As privacy regulations tighten, organizations are turning to synthetic data. That is data that is artificially generated but mimics real world patterns. Alongside this are techniques like differential privacy, federated learning, and homomorphic encryption. These are ways of analyzing data without exposing sensitive information. The use cases for this are training AI models without using real patient or customer data, or sharing insights across organizations without sharing the raw data. The implications are that data-driven work will need to balance innovation with ethics. Professionals will need to understand how these technologies protect people, especially in sectors like healthcare, education, and finance. Data democratization and the rise of citizen analysts. The movement to put data tools in everyone's hands continues to grow. Intuitive platforms and AI driven assistants, professionals across roles from HR to marketing to field operations are becoming empowered to explore data on their own. They have tools like Tableau, Power BI, Looker Studio, no code analytics apps, and AI enhanced Google and Excel spreadsheets. The trend is that data is no longer confined to data teams. It's becoming language spoken across departments. Data literacy will become a standard expectation, like email or presentation skills once were. The expanding universe of data types. Tomorrow's data won't just come from clicks and transactions. It will include video and audio transcripts, satellite and drone imagery, emotion detection, biometric signals, voice commands, and digital assistants. As formats diversify, the need for smarter tools and clearer policies around use, ownership, and bias will grow. Professionals must become more comfortable working with unstructured and unconventional data. Ethics, trust, and data transparency. Public trust in data driven systems is fragile. Scandals involving surveillance, algorithmic bias, and data misuse have raised awareness and expectations. The future priorities include transparent data practices, explainable AI, which is systems that show how decisions were made, inclusion and equity in data designs and analysis. You, as a professional, can advocate for ethical practices, ask questions about who benefits from the data, who is harmed, and how your organization is building trust with the public and its employees. Lifelong data literacy. As data becomes a central language of work, data literacy will become a core competency. Not everyone needs to code, but everyone should be able to interpret charts and trends, ask clear, informed questions, evaluate data claims and quality, and spot misleading statistics. Learning to work with data is not really optional. It's part of being an effective, responsible professional in any field. The key takeaways are big data is evolving alongside AI, automation, privacy technology, and real time systems. More people will be expected to use data tools regardless of their technical background. Understanding trends like edge computing, synthetic data, and ethical AI is key to staying relevant. Lifelong learning and data literacy will define professional success and a data driven future. So we've now reached the end of this little mini series, but in a lot of ways, it's just the beginning. Big data may seem intimidating at first glance. The terminology can feel dense, the tools unfamiliar, and the pace of change overwhelming. But the truth is, you don't need to be a data scientist or engineer to thrive in a data driven world. You just need curiosity, clarity, and the confidence to engage. Throughout this mini series, you've explored what big data is, where it comes from, how it's processed, and how it's used. You've learned about real world applications, common tools, emerging trends, and ethical considerations that must shape our use of this information. Most importantly, you've seen that data is not just a technical asset, it's a strategic one. And that means everyone has a role to play. Whether you're a team lead, a manager, a public servant, clinician, marketer, or policy advisor, your ability to interpret, question, and act on data will increasingly shape the outcomes you deliver. Data fluency is becoming an essential skill, just as financial literacy or communication skills, and it's absolutely within your reach. You don't need to know every algorithm. You don't know how to write Python or create a database, but you need to be able to ask the right questions, spot the story behind the numbers, and collaborate confidently with data professionals. So if you've made it this far, you have the most important skill, and that's a willingness to learn. So what is next? Start small, ask more questions, and look at the data behind your decisions. Explore the tools you already have access to, explore tools that you would like to learn more about, and practice. Join conversations about data ethics in your organization and challenge assumptions, especially your own. Big data isn't just about the future, it's already here. The good news is you're ready to meet it, not with fear, but with curiosity, clarity, and capability. Use this quick checklist to assess your team or organization's readiness to work with big data. Do we know what key decisions we want to inform with this data? Do we have access to relevant data sources, internal or external? Are roles and responsibilities for data projects clearly defined? Do we use any dashboards, visualizations, or reports regularly? Are there data privacy and governance policies in place? Are non-technical team members comfortable using basic data tools? If you answered no to 3 or more questions, consider starting small with a pilot project or training session. Better data questions checklist. Before you request a report or launch a data initiative, review the following. What decision will this data support? What time frame or time range matters? Example, daily, weekly, quarterly. What level of detail is required? Summary or granular? Are we comparing across segments? For example, regions, teams, product lines? What action will we take based on the results? Better questions lead to better insights and better outcomes. Here's our sample dashboard walkthrough guide. When reviewing a dashboard or report, scan the key metrics. Are they aligned with your goals or KPIs? Check filters. What data is included or excluded? For example, dates, locations, user types. Look for trends. Is performance improving, declining, or plateauing? Ask about the outliers. Are there any spikes, dips, or anomalies that deserve investigation? Request plain language summaries. What should we take away from this data? Encourage a habit of regular review and discussion. There are some common tools and what they do as a quick reference guide. You have Excel or Google Sheets. These are good for organizing, calculating, and exploring structured data, and best for entry level analysis. You've got Tableau or Power BI. They're great at creating interactive dashboards and reports, best for business intelligence. Google Looker Studio offers free visualization for Google connected data, and it's best for lightweight reporting. Zapier or Make are good for automating repetitive tasks and data flows, best for workflow efficiency. Airtable is for blending spreadsheet and database capabilities, best for collaborative tracking. And you've got Kaggle or Google Cloud Labs. This is great for exploring data sets and practicing analytics, best for learning and experimentation. Here is an example project kickstart template. You need a project name, identify what problem you're trying to solve. So in this example, we're saying a customer attention dashboard, and we want to identify and address declining repeat customer rates in key regions. Identify who your key stakeholders are. So that could be sales, marketing, customer support, and the BI team in this example. And then what data do you need? In this case, we need customer purchase history, support ticket logs, and regional segmentation data. What decisions will this support? It could be regional campaign adjustments, customer service enhancements, or loyalty program design. Here's an example of a data collaboration planning sheet to help you get started on your data project. Identify who your point of contact is. Could it be a data analyst, engineer, or product owner? How often do you need to meet or check in? Weekly, bi-weekly, monthly, maybe even quarterly for some projects? What is the preferred format for updates? Dashboards, slide decks, reports, email summaries? And what is your review schedule? Set recurring time to review data outputs and take action.